Hello everyone, my name is Devi Belamkonda and I'm working as a technical marketing engineer focusing on Cisco software defined access. In this video, we will delve into our approach to enhancing the ease of accessing essential services within customer environments. This encompasses shared services and internet access, all designed to simplify deployment and minimize the need for extensive configurations. So to begin our exploration, let's uncover the rationale behind the implementation of SD-Access Extranet. In Cisco's SD-Access framework, endpoints consistently reside within an overlay virtual network. Nevertheless, specific critical services such as DHCP, DNS, and Internet access necessitate sharing across multiple SD-Access Layer 3 virtual networks. So these services, commonly referred to as shared services, cater to endpoints spanning across Layer 3 virtual networks. So presently, the sharing of the shared services across multiple layer 3 virtual networks is achieved through an external device like a peer router device or a fusion router or a switch or a firewall by any means. However, some clients prefer to circumvent the investment, configuration, and upkeep associated with the fusion and a peer device. So the inception of the SD-Access Extranet feature directly addresses this issue, so serving as a solution that enables hosts to attain essential services like internet and shared service access. So importantly, it eliminates the necessity for a peer device in these cases. So this empowerment grants clients the capability to accomplish route leaking tailored to their specific requirements, all without relying on an external peer device. How is this amazing functionality achieved? And this is achieved with two key terms or things called as providers and subscribers. Providers, as the name suggests, or a provider virtual network refers to entities or systems that offer services like shared services or internet access. And these services encompass a range of commonly used resources such as DHCP, DNS, and general internet connectivity. And the subscribers or a subscriber virtual network contains the hosts, endpoints, and devices needing access to those shared services. So, how do we define the relationship between these entities, you may ask? And this is where the extranet policy comes into play. So the extranet policy consists of a set of rules that specify the connection between the provider virtual network and one or more subscriber virtual network in a policy. So it basically outlines the relationship between these networks, ensuring a smooth communication and access to the critical services such as shared services or internet. So in essence, the extranet policy governs the interaction between the provider virtual network and multiple subscriber virtual networks, ensuring a cohesive network environment. Let's dig into it a bit. So what is this extranet? So the LISP extranet offers a flexible and a scalable approach to grant access to shared services and internet for endpoints within the SD-Access fabric. And this simplifies the deployment of the SD-Access fabric by providing a policy-based method of leaking virtual routing and forwarding, basically the VRFs, and by addressing the route leaking natively within the LISP architecture, the LISP extranet helps avoid the need of route leaking outside of the fabric site. So a virtual network or an extranet policy defines the relationship between a provider virtual network and one or more subscriber virtual networks, as we discussed. And the provider virtual network contains the details of those critical services. When examining the knowledge we have acquired so far and visualizing it in a topology, we observe the current SD-access environment without extranet. And in this scenario, we are required to extend the VRF instances to the external world and perform route leaking at the peer device or fusion. And with the assistance of our Cisco DNA Center, we can expand the virtual network information from the border node to the outside world using a peer device, which can be any device which performs a layer 3 functions. And this expansion is achieved through the utilization of the EBGP, which is automatically managed by the controller, which is our DNA Center. So we simply need to ensure the configurations on the border node and the peer device are aligned. Although the peer device is not owned by the controller, the DNA Center templates can be utilized to automate the configuration process if desired. So in case of extranet, route leaking at the peer device is not necessary for shared services and critical service access for hosts inside the fabric. The reason being, as it occurs naturally within the LISP control plane node and the transit control plane nodes in an SD-access transit scenario which connects multiple sites. And this overall process basically eliminates the need for explicit route leaking at the peer device, and we only need to perform a layer 3 BGP handoff for only provider virtual networks, unlike every other virtual network without any extranet policy. When building the extranet policy, it is important to adhere to some of the rules. And the policies can only be created between provider virtual networks and subscriber virtual networks, and not between provider to provider or subscriber to subscriber. And an extranet policy consists of a single provider VN and one or more subscriber virtual networks. A provider VN can be a dedicated virtual network or an infra virtual network, which is part of the DNA center, but it cannot be a subscriber virtual network. The design does not facilitate communication between VRFs, between subscriber VRFs. If we take an example of a corporate or an engineering, if devices need to communicate, they should be placed in the same VRF. If communication within the same VRF needs to be restricted, then SGTs or security group tags should be utilized. The combination of VRFs or virtual networks and SGTs provides macro and micro segmentation respectively, allowing for comprehensive control over the communication. Let us now proceed with a quick demo to showcase what we discussed. So in this topology, we have a host that is attempting to access shared services such as DHCP, which is outside of a fabric, so that the host can automatically get the IP address and be onboarded onto the network. And to achieve this without any route leaking, we will create an extranet policy called first policy. And in this policy, we will designate a provider virtual network named services and a subscriber virtual network named campus, where the hosts are located. So presenting the Cisco DNA Center main dashboard. So let's navigate to fabric site K, where we have three nodes: border, control plane, and edge nodes. And now that we have established the basic fabric site, let's proceed to virtual networks. Here we can create or modify the extranet policies workflow. We will create an extranet policy called first policy as demonstrated in the previous slide. And next we will select, and here we will select the provider and the subscriber virtual networks. For the provider, we choose services, and for the subscriber, we will select campus. And it's worth noting that multiple subscribers can be included in the same policy. So moving to the next screen, we can selectively push the policies to the fabric sites of our choice. Here is the summary of a policy, and we can proceed to push or deploy it. That's all. Once the policy is pushed, now let's verify how the policy is applied. If we examine the control plane node, this is the control plane node, we can observe that the virtual networks or VRFs for both campus and services, which are provider and subscriber VN, are present. And here is the extranet policy that is pushed, and we can actually check the exact running configuration also by looking at the control plane node, as the extranet policy resides only on the control plane nodes because that is the heart and soul of the fabric. The host connecting to the fabric edge actually received an IP address of 8.2 with a MAC address ending with 0BC4. Let's quickly go to the fabric edge to see if this is indeed onboarded to confirm. If we go to the fabric edge, and we will see that there is an SPI of VLAN 81 with an IP address of 172.16.8.1, which belongs to campus virtual network or VRF, representing the subscriber VN. And if we check the device tracking database on the fabric edge, it indeed displays the details of our host. And this demonstrates how simple it has become to onboard networks with the power of LISP extranet. So whatever we have seen is awesome, but that is for a single site. The beauty with the LISP extranet is we do support this for a multi-site scenario as well, which are connected by our SD-Access transit. With SD-Access multi-site, the VN policy or an extranet policy needs to be configured on all control plane devices, including the local control planes and the transit control plane nodes, which are specific to our SD-Access network. The extranet policy should be consistent and aggregated across all sites to prevent any unintended VRF issues such as leaking. This requirement is automatically taken care by our controller DNS Center automation. So to achieve this consistent policy configuration across the SD-Access multi-site, a feature is developed within the devices where the extranet policy config propagation has been developed under the hood. And this allows the policy to be configured on the transit control plane nodes, which then propagates the policy to all the control plane nodes in the respective fabric sites. And this policy is propagated from the transit CP to fabric site borders, and from fabric site borders to the local control plane nodes using our existing LISP publisher and subscriber architecture. So which brings us to a very important point, that the LISP extranet is supported with our latest LISP publisher and subscriber control plane architecture only. And once the policy is propagated to all control plane nodes, its functionality is similar to the extranet policy for an IP transit or a single fabric site. And the extranet policy can be applied to all sites connected via SD-Access transit simultaneously through our controller UI workflow. And the extranet policy resides on the local control plane nodes and the transit control plane nodes, with the main policy residing on the transit control plane nodes in an SD-Access scenario, and the skeleton of the policy residing on the respective site local control plane nodes. So let's now observe a quick simulation in a multi-site scenario. We have two fabric sites, 22 and 23, connected via SD-Access transit, and the critical services are accessed via fabric site 22's borders. The workflow remains exactly identical, and the only difference is that we will be pushing the policies to multiple control plane nodes across sites, including the transit control plane nodes. And this is all done automatically. Allow me to quickly show you. And for the simulation, let's consider we are pushing the extranet policy called extranet policy 1 services, which is just the name of the policy. And this policy provides services with the provider virtual network, which is services, and the subscriber virtual network, which is named as campus, which both are our respective virtual networks. The workflow remains unchanged, and as a reminder from our previous demonstration, if you select a fabric site that is connected to the SD-Access transit, all the sites connected to the transit will be automatically selected. And the corresponding extranet policy will then be pushed to ensure seamless configuration across all the relevant sites. If you see here, the policy is actually pushed to two different sites, site 22 and 23. By examining the extranet policy applied in our SD-Access transit topology, we can observe that the primary extranet policy is distributed to the transit control plane nodes, where you can see the policy is actually pushed to this transit control plane node here. And additionally, a basic framework of a policy is propagated to site local control plane nodes, such as this and this. This basically ensures the policy synchronization across all sites. And this approach facilitates the dissemination of configuration changes across the network. And this showcases the ease with which we can streamline essential service access in our networks, making them well prepared for our future network environments. And that concludes my presentation. Thank you for your attention and have a wonderful day.